Hello, everyone. My name is Luwen Zhang, Product Manager of Vinchin. Thanks for joining oVirt 2021 online conference. It's my honor to present you how to use Vinchin backup and recovery to strengthen your oVirt data resiliency and protection. Last year, we've had the honor to participate in oVirt 2020 online conference and had introduced lots of innovative features of Vinchin backup and recovery, including image-based hypervisor level backup, incremental and forever incremental backup with SpeedKit support, data deduplication, compression, and bit detector for backup data reduction, LAN-Free backup, and more. And for virtual machine restore, including LAN-Free restore, instant restore and migration, file level granular restore, and also offsite DR and cloud DR functionalities. This year, we are honored to be here again to share something new with you. Recently, we are going to release a new major version, 6.5, which will bring some more innovative features to protect your oVirt virtual infrastructure, including the oVirt imageio and CBT implementation, cross-platform restore, ransomware protection, multi-tenancy support, and some feature improvements. Before introducing the new feature of backing up through imageio API, I'd like to first introduce the working principles of the existing backup architectures, LAN-based backup using backup plugin, and LAN-Free backup. Here's the working principle of the LAN-based backup using Vinchin backup plugin for oVirt virtualization. The deployment topology is as shown in the diagram. Vinchin can be either installed as a virtual machine or can be installed on a physical machine. And Vinchin connects to the oVirt virtual infrastructure by using oVirt Engine REST API. And our lightweight backup plugin will be installed on each of the oVirt nodes on the hypervisor layer. When running a backup job session, the VM info, snapshot creation, deletion will be done through the oVirt REST API. The transmission of the oVirt VM data will be conducted by the backup plugin on the oVirt node. And by default, the transmission will go through the management network through the hypervisor layer. But if you have a dedicated network for backup, both the oVirt nodes and the Vinchin server have been connected to that network, you can change the listening IP of the backup plugin from oVirt node command line interface to enable transmission over the dedicated backup network. But in our new version, the listening IP will be configurable directly from Vinchin Web Console. Okay, that's a brief overview of the LAN-based backup using Vinchin backup plugin. Here's the working principle of LAN-Free backup over a storage area network. The deployment of Vinchin software must use a physical server. Because only a physical server with fiber channel adapter or dedicated network interface will enable Vinchin to connect directly to the FC sign or IP sign. And the production nodes of the oVirt need to be mapped and mounted to Vinchin server as its LAN-Free path. So when a backup begins, Vinchin server will be able to directly access the oVirt VM virtual disks on the oVirt production nodes through SIGE. The transmission will not pass through the oVirt node hypervisor layer and also will not pass through the management or production network. So LAN-Free backup could be very efficient and has the minimum impact on the oVirt production environment. About the LAN-Free path settings, while the oVirt nodes had been mapped to Vinchin, the logic volumes metadata will be mounted in read-only permission. So you don't have to worry about Vinchin messes with the LVM metadata. And write to the oVirt nonce will only happen when you try to restore a virtual machine through SAN. That's for the LAN-Free backup. Here's a new backup option implemented in our new version, which utilizes the oVirt imageio API. The deployment is similar to LAN-based backup using Vinchin Backup plugin. But with imageio, no backup plugin installation is required anymore. Everything will go through oVirt REST API and the imageio API. Currently, when backing up oVirt VMs using imageio, by default, the transmission will go through management or production network. Later on, we are going to implement backup network selection, the same as using the backup plugin. And by the way, imageio API also enables Vinchin to take advantage of the oVirt changed block tracking, the CBT technology. Here, let's take a look at the basic process for incremental backup by using imageio and the CBT API. When a backup started by Vinchin, the first step, it will create a backup according to the dependent checkpoint ID of the previous backup and then generate an incremental checkpoint. If the disk format is wrong, before creating backup, a dummy snapshot for CBT will be created first. If it's QCOW2 format, a snapshot creation is not required. It will directly create a backup. And after the backup creation, Vinchin will get the current checkpoint ID and then request oVirt to create image transfer for each virtual disk according to the disk ID and the backup ID. The first three steps will use the oVirt REST API. On step 4 and step 5, Vinchin will use the imageio API to get a list of the changed blocks for each image transfer, and then download the changed data blocks from oVirt imageio. And then on step 6, 7, and 8, Vinchin will use oVirt REST API again to finalize the image transfer, delete checkpoints, and then finalize the backup to end the backup job session. The whole process is standardized using oVirt REST API and the imageio API. So here, let me make a summary of the Vinchin supported incremental backup options. Of course, full backup is also included. Both LAN and LAN-free backup had been implemented on our current and the previous versions. Now we had implemented the third option, imageio API, which will be available in our new version to be released. And then, LAN-free, ordinary, and the speed kit can be used as the incremental mode. For imageio, CBT is supported. As for transmission network, both LAN-based backup using backup plugin or backup through imageio, the data transfer will be done over the LAN or over a dedicated backup network. 3 options now. Which would be the best for you? Actually, we implemented imageio to replace the old LAN-based backup using backup plugin. Imageio would be the standardized and recommended way to backup your oVirt VMs through LAN. So if you are running oVirt 4.4.1 or higher versions, please choose imageio. But if you are running older versions, you are still able to use the old way. Just don't forget to install the backup plugin on the oVirt nodes. Okay, for oVirt VM backup, we had implemented zeroed blocks exclusion from source, bit detector, and built-in data deduplication and compression to minimize the data to be transmitted and the data to be saved in the backup storage. Among those, the zeroed blocks exclusion from source means to not transfer any zeroed data blocks from the source VM to Vinchin. This will be supported soon in the new version, and it also works seamlessly with the imageio API. Imageio will tell Vinchin the data block is zeroed and can then skip these zeroed blocks to not transfer them. This mechanism can greatly reduce the data to be transferred. As for bit detector, it's a useful feature to exclude the swap file blocks, deleted file blocks, and the unpartitioned spaces from Windows VMs, the NTFS file system. These data blocks will also be excluded from the source and also works when backing up through imageio API. And for data deduplication and compression, these two processes will be conducted on Vinchin side. The valid data blocks will be deduplicated and compressed before writing into the backup storage. For VM restore, Vinchin has a unique technology which is named Virtual Full Backup. It is a backstage feature which cannot be seen by the users. A backup chain inside Vinchin backup storage can be virtually mapped as a single full restore point for VM restoration. The required data blocks to be restored a VM to a specific point of time are mapped into an index file. This can be done instantly without merging or reorganizing the data blocks to an actual full virtual disk file. When transferring the data blocks to restore the VM using imageio API, Vinchin can directly transfer the required data blocks indicated in the index file and write the data blocks to the newly created virtual disk according to the data blocks offset. For zero data blocks, the imageio also has its interface to directly write zeroed blocks without the need to generate and transfer the zeroed blocks from Vinchin side. Furthermore, because of the flexibility of imageio API, it allows Vinchin to transfer necessary data blocks and skip those unnecessary blocks. So as a result, it also allows Vinchin to create multiple threads to process the VM restore transmission simultaneously, which can dramatically improve the VM restore efficiencies. The virtual full backup and imageio API combination can be applied to full VM restore, instant restore, and also live migration functionalities. For VM restore, a new advanced restore feature, the cross-platform restore feature, which will be available in the Vinchin new version, is also as known as V2V. It can be used to migrate virtual machines from other virtualizations to oVirt virtualization. The basic working principle of V2V can be summarized as backing up VMs from other virtualizations and restore as oVirt VMs. For cross-platform restore, there are mainly three parts of work to be done. First part, the basic VM configurations, including VM name, CPUs, RAM size, VM status, and boot mode. They mostly will be used the original settings, but they are all configurable if needed, like increase or decrease the RAM size. The second part, virtual disk, the most important part is the virtual disk format converting. Let's take VMware as an example. The VMware VM disk format is VMDK. Vinchin will back up the virtual disk data and save as Vinchin format. When restoring, the data will be converted as raw or QCOW2 format, which is used by oVirt. As for the target storage domain, virtual disk name, and interface type, there will be suggested default settings, but can be customized if needed. The third part, virtual network, the target network and MAC address are customizable. And for the interface type, there will be a suggested default settings. Here is a diagram showing the cross-platform restore process for both full VM restore and instant VM restore. Yes, that's right. For cross-platform restore, except full VM restore, you can also use instant restore feature to do this. Let's first check the process of full VM restore. A VM backup from VMware ESXi server, Vinchin will first convert the VM configurations to oVirt and request oVirt API for VM creation using the converted VM configurations. After the VM creation, the VM backup data will be automatically converted to raw or QCOW2 format and transferred to the oVirt storage domain via LAN-Free or imageio API. After the virtual disk is ready, then you can put the VM on oVirt and then the restoration will be done. For instant restore, the process is like this. Vinchin will first use the existing VMware backup to create and mount an NFS storage using the oVirt REST API. After this, Vinchin converts the VM configurations from VMware to oVirt and request from oVirt REST API to create a new VM. After the VM creation, then boot the VM using the NFS storage mounted by Vinchin. At this moment, the VM will be up running on oVirt infrastructure. And later on, you can optionally migrate the VM data from Vinchin storage to oVirt storage domain. The migration process is similar as a full VM cross-platform restore. The only difference is migration will involve migrating the new data generated during instant restore VM runtime. This can guarantee the data consistency of the migrated VM. Here's a new feature which can protect your oVirt backup data against ransomware and other malwares. Let's see how it works. On the Vinchin new version, a daemon process will be applied to monitor the IO requests from all applications within Vinchin backup infrastructure, including Vinchin server and Vinchin node. Only the IO requests from Vinchin applications are allowed to write and modify the backup data inside Vinchin backup storage. The requests from other applications will be blocked. To prevent the malwares to disguise as Vinchin applications, the daemon process will also protect Vinchin application binaries. For example, the backup service application, backup copy application, and backup archive applications. So a security closed loop is formed within Vinchin backup and recovery. And as a result, your on-site backup data, on-site and off-site backup copy data, on-site and cloud archive data are all safe from ransomware and other malwares. Okay, it's demo time. Two features I'd like to show you with this demo. First, how backup and restore works with imageio. And second, how cross-platform restore works. Okay, let's first create a backup job for oVirt using oVirt imageio. Let's select a virtual machine from oVirt virtual infrastructure and select the backup storage. And next, set up the backup strategy and select the transmission method. Here, I will select imageio, and the default incremental mode would be CBT. And next, submit. And let me manually stop the backup job. Okay, the job is running now. So let me click on the job name to view some job details. Okay, the transmission is started now. Here's the job progress. And here's the job process flow. Actually, I'm now running this environment through a gigabyte network. But as you can see, the peak processing speed has exceeded 1 gigabyte. This is because some of the zero data blocks or some other unnecessary data blocks had been excluded from the source. They've not been transferred from the VM to from oVirt to Vinchin. So the processing speed is very fast with those kind of data blocks. Okay, the transmission is done. And I'm going to test an incremental backup with this job. Before that, I will try to write some zero data blocks on this virtual machine and see how it works. Okay, I have writing 1 gigabyte of zero data blocks to this virtual machine. And now let me start an incremental backup. Okay, the backup is done, and let's check on the backup data. As we can see, the data size for this incremental backup is 1 GB, but the writing size is only 2.4 megabytes because those data blocks I wrote into the virtual machine, they are all zero data blocks. Okay, that's for backup, VM backup using oVirt imageio API. And for the VM restore using the imageio API, it's also supported. And let's create a restore job. And for the transmission, we are still able to use imageio because the restore process is just the reversed process as backup. So I will not show you the detailed. Next, I will show you how cross-platform works on Vinchin. I'm going to take an instant restore as an example. Let's create an instant restore job using VMware backup and select oVirt node. Those settings can be customized, but you can use the suggested settings. And let's power on the VM after restore. And okay. And let's start the job and check on the job running details. Now it's creating an instant restore storage, an NFS storage. It will be created based on the backups inside Vinchin, and then mount this storage to the oVirt platform by using the oVirt REST API. Now it's creating the instant restore virtual machine. Let's take a look. Here, the virtual machine is created. And now the restore process is done, and the virtual machine should be powered on now. Okay, check on the console. Okay, it's up running now. Before performing migration job, I will write some data into this instant restore virtual machine. I'm going to create a text file and put in some random data into this file. Okay, let's do migration. The job tab had been changed to migration. And as we can see, this is the instant restore virtual machine, and this is the migrate virtual machine. Here's the job progress. The transmission of the migration job will be performed in 3 stages. The first stage, the original backup data will be transferred to the oVirt storage domain. And after that, on stage 2, some cache data generated during the instant restore runtime will be migrated. And on stage 3, the instant restore virtual machine will be powered off. And during the power off process, there are some final cache data will be generated. And this data will also be migrated to the oVirt storage domain. So after these 3 stages of migration, this can guarantee the data consistency of the migrated virtual machine. Okay, it's now trying to process the cache data, and the job should be done shortly. Okay, the migration is done. And let's check on oVirt platform. The migrated virtual machine is still not up running yet. Let's run it manually. Okay, check the console. Let's log in and check the text file I have just created from instant restore. Okay, so this file is now inside the virtual machine, the migrated virtual machine. So the whole process is done, and also it guarantees data consistency of this virtual machine. Okay, so now we are able to stop the instant restore job. And the instant restore virtual machine will be deleted within this process. And also the NFS storage will be unmounted from oVirt platform. And you will have the migrated virtual machine up running in your oVirt platform. Actually, this virtual machine is from VMware. Now we have migrated it from VMware to oVirt by using Vinchin's instant restore and migration feature. Okay, that's all for my presentation today. Thanks for watching. If you are interested in Vinchin backup and recovery and want to get to know more, stay connected with us. Thanks again, and I will see you next year. Bye-bye. Bye.